Hey guys, welcome to my channel and I'm back again with another really interesting video. In this video guys, we are going to solve a coding interview question number 99, recover binary search tree. So without taking any time further, let's get started with the problem statement. So basically guys, the problem statement is very simple and short, that we are just given a root of a binary search tree, and in this binary search tree, the values of exactly two nodes were swapped by mistake. So for example, you can see that this is the binary search tree where we have the root as 1 and the left node is 3. So if you know, in binary search tree, the left node always has to be smaller than the root node, and the right node always have to be larger than the or greater than the root node or the parent node. So we know that these two nodes are definitely not having the right value because 3 is greater than 1. So we need to recover this tree without changing the structure of the tree, and we can do that by swapping these two values. So once we swap 1 and 3, then you will see that the tree now looks like this, which is the perfect binary search tree where all the values are in the correct position. Another example guys, you can see that here the root node and one of the leaf node is actually the wrong node, and we have to swap the root node with this value. And once you do that, you can see that your tree is now completely recovered. You have got the root node as 2, where 1 is smaller than 2, 4 is greater than 2, and 3 is also greater than 2, but 3 is smaller than 4. So that becomes the perfect left node of 4. The constraints are that the number of nodes in the tree are in the range from 2 to 1000, and the node values go from 2 raised to power 31 to 2 raised to power 31 minus 1. Okay. Now a solution using order of n space is very straightforward. Can we devise a constant order of 1 space solution? So what we want to do guys, we want to solve this problem in a way that we don't use any extra space. So we just swap the nodes in the tree itself. We don't create a new tree with this tree, but we are going to also make sure that we try to optimize it with the smallest time complexity as well. So let's get started with the solution part. So first of all guys, we are going to actually write down the solution approach for this. So first thing first guys, you can see that in this binary search tree, if we do the in order traversal, so if there is a binary search tree and you do an in order traversal, it will always lead to a sorted array. But in this case, if you do an in order traversal, will that lead to a sorted array? And the answer is no, because for example in this case, if you do an in order traversal, then you will actually turn out to be 3, and then so first of all you will get the answer as 2, then you get 3, and then you get 1, right? So you are obviously getting the wrong answer here. So we want to make sure that if we do the in order traversal of this binary search tree, then it comes out to be correct. So if you do the in order traversal guys, your actually answer will become 3, and then the right node of 3, which is 2, and then finally the parent node, which is 1. So 3, 2, 1 will become your answer. That is absolutely incorrect. Whereas if you do the in order traversal of the new tree, your answer will actually become equals to 1, which is the left node of your root node, then the right node of 1, which is 2, and then finally the root node in general, so which is 1, 2 and 3, and that's the correct in order traversal in a sorted way. So now we know, I mean that's one of the biggest hint guys, that if you do an in order traversal, you should end up in a sorted array. And if you are not ending up in a sorted array, so if you are ending like this, it means that the node that you have, so let's say this is my current node. So let's say if you are at node number 2, which is your current node, and you look at its previous node. So for 2, the previous node is 3, and is 3 the correct node? And that you can check, right? You can check the value of the previous node and compare that with the current node. So is 3 greater than 2? And the answer is yes. So that's why this is the wrong node. So once you find out that the previous node of your current node is incorrect, the previous node of your current node is actually greater than it instead of smaller than, then you can say that the first node, which is the wrong node, is 3, right? Now you go to the next node, right? So now I go to this 1. Now I go to this one. Now I look at this one and I look at the previous of 1 and I see, yeah, okay. So this 2 is also wrong. Obviously, if 2 nodes are wrong, then for this one also the 2 is wrong, right? So you again look at the previous node, you find out, oh, this node does not have the value which it should have. So 2 should have a value, which 2 is having a value which is greater than your current node. And actually it should be the reverse, right? Your current node should have a value greater than your previous node. So this is incorrect. So now your first bad node or your first incorrect node is already filled with the value 3. So then you create a second pointer and then you add that the second pointer is incorrect. So second pointer will get the value now. But the second pointer is incorrect, but the second pointer this time will get the value as the root node, the current node itself, right? Because in this case you can see that the previous value is 2, next value is 1. So if your first pointer is already having the incorrect node value, then for your second pointer you cannot assign it the previous value. For your second pointer, if your current node is actually smaller than your previous node, that means your current node itself is incorrect. Because now if you see, if your first node was 3 and your second node is 1, and if you just swap 1 with 3, what's going to happen? So if I just swap 1 and I put 3 here, automatically your combination became correct. So the first time you find a previous node which is greater than your current node, that means your previous node is wrong. But the second time you find a previous node which is greater than your current node, it means that the previous node was at the correct position, but it was the current node which is the incorrect node, and now you need to swap your current node with your first node, okay, the first bad node which you found. And there you go, guys. Just with in-order traversal, by finding out which was the first incorrect node and which is the second incorrect node, you just swap these two values together, and without taking any extra space, you will actually end up recovering your binary search tree. Okay. So now that we know a little bit of approach of how we are going to solve this, it is going to become much more clearer once we start the coding part. So first of all, we need to create some pointers, right? So first of all, I need to create a previous pointer. So this previous pointer is going to be null. Then I need to create so let's make them global variables, right? Let's not make them inside this. Let's make them global variables. So first of all, we need to create the previous node. Then we need to create our first incorrect node, which is also going to be null. Then we need to create our second incorrect node, which is also going to be null. Okay. Now we create a function which is going to do the in-order traversal, because how else we are going to know that your traversal is correct and your previous node and the current node are correctly placed or incorrectly placed. You are going to do it with the help of in-order traversal. So let's write in-order and 3-node root, right? And in-order traversal is simple, right? If your root is equals to null, it means you are at the, you just return, right? You can't traverse any further. But if your root is not equals to null, then you traverse your first left subtree, so root dot left, then you traverse the root, and then you traverse the root right. Okay. So now first of all, I am going to traverse the left subtree. Now when I am at the root, I am going to check if previous is not equals to null and previous dot value. So if it's a correct in order, the previous value is going to be smaller than the current root value. But if it's incorrect, the previous value is going to be greater than the current root value. If it is greater than the current root value, that means that we need to find out if the first incorrect node has been found or not. So if first is equals to null, then it means that the previous node was incorrect. So first becomes equals to previous. But else case, if first is not equals to null, that means the first incorrect node has already been found. Now that means that the current node is incorrect itself. So then you do second becomes equals to your root, right? Now if this is not the case, so let's say if previous is not equals to null and previous dot value is actually smaller than the root value. So if previous is actually correct, that means that until this time your in order traversal is going fine. Then you just assign your previous to the current value. That means you are just now going ahead in your traversal, and now your previous becomes your current node, and then you move to the next node, and the next node in order traversal is going to be your right node. So in order root dot right, because now you start traversing the right subtree. So what we are going to do in this recover tree function, we are going to call the in order root. Okay, and again first base condition we will check that if the root is null itself, then it means that we don't need to recover any tree, so we just return. But if the root is not equals to null, we do the in order traversal of root, and after this in order we will have the first and the second node which we need to swap. So integer temp becomes equals to first dot val. So this is just a simple code for swapping. So first dot val becomes equals to second dot val, and second dot val becomes equals to temp. Okay, now let's run this code, guys. Let's see if this works for our test cases. And you can see there is definitely some issue here. Let's see what was the issue. So we have our second value, second dot val is actually getting false. So let's see, maybe we didn't assign the second value. So if first is equals to null, then first becomes equals to prev. But if first is not equals to null, or in any case, your second will actually becomes equals to your root value, right? Because if first is equals to null, then also first will become previous. But if first is not equals to null, then your second will become your current value. So in any ways, your second will become your current value. Let's see if now the second value is getting assigned correctly. And there you go, guys. You can see that now it basically works. So you can see that our solution has been accepted. Now let's look at the time complexity, guys, very quickly. So you can see here that we are doing in order traversal, and in order traversal the time complexity is order of n. So simply time complexity is order of n. And what about the space complexity, guys? So space complexity actually is order of 1 if you are not considering the recursion time complexity. But if you are considering recursion with in order traversal, then the space complexity also becomes order of n. But we have not used any extra data structure to store this value. So I would say that if you ignore the recursive stack, the space complexity order 1 here. Okay, but it depends upon your interview, guys. If you're interviewing, then definitely mention that if you don't consider the recursive stack, the space complexity is order of 1. But if you consider it, then it becomes order of n. Okay, so that was the video, guys. That was the answer to this problem statement. I hope you guys liked this video, and I hope you learned something from it. If it did help you in any way, guys, then please do not forget to like this video, share this video with your friends. And if you have any questions, comments, suggestions for me, please do write down in the comment section below. I would be happy to read them. In the end, guys, if you have not yet subscribed to my channel, then please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video. Until then, take care and bye bye.